Section 1.1 is about linear equations. What do we mean by a linear equation? Linear equation is an equation that can be written as ax plus b equal to 0, where a and b are constants. I mean, they can be considered as real numbers, and x is the variable, and a is not equal to 0, because if a is equal to 0, the first term will disappear. It becomes 0 times x, that's 0. We no longer have x in the equation, and that means it's not a linear equation. And this equation is linear because the power of the variable is 1, but we don't write the 1 here. If we have a linear equation, we just write ax plus b. We don't write the power here. But it's well understood that the power is 1. The power over the variable is 1. Some examples of linear and nonlinear equations. 3x plus 1 equals 4. This is linear equation because it's written in this form. As we can see, this is a, this is b, and this need not be 0 actually. This can be any value, any constant, but we would like to write it in the standard form. This is called standard form, so we write it as 0. How? We can subtract 4 from both sides and write the equation as 3x. Now 1 minus 4 is negative 3 equals 4 minus 4 is 0, so we could write it in that standard form. The right hand side is 0. This is linear because if we look at the power of x, the power is 1. So yes, it's linear. What about square root x plus 2 equals 5? Is this a linear equation? If we look at, we need to focus on the variable. The variable is x, and the power of x, how can we rewrite this as x raised to some power? The square root is the power 1/2. So x to 1/2 plus 2 equals 5. As we can see, the power is not equal to 1. That means it's not linear, non-linear equation. Also, if we have 1 over x equals negative 2, as we can see, x is not in the numerator. I mean, it's in the denominator. So the power of x actually is negative, because if we bring this up here, it becomes x to negative 1 equals negative 2. So the power is negative. It's not equal to 1. Or if you don't want to deal with powers, you can simply say that since the standard form contains x in the numerator, if we imagine that this is ax over 1 plus b equals 0, the x is not in the denominator, but here x is in the denominator. So that means it's non-linear, not linear equation. What about the equation x squared plus 2x plus square root 2 equals 0? Now we need to focus on the variables. If you look at the variable here, the variable is x, but we have some powers. The power here is 2, the power here is 1, but the highest power is not equal to 1. And that means this is not linear, because the degree of this function, or the left-hand side part, is 2. It's not equal to 1. I mean, we are looking for the highest power, the largest power for x. So if we can write the equation in this form, ax plus b equals 0, I mean the power of x is 1, that means we have a linear equation. Now, how to solve linear equations? If the linear equation is written in the standard form or something similar to the standard form, then it becomes very easy to solve it. For example, 3x plus 1 equals 5. In order to solve this equation, we need to isolate x. Now, how to isolate x? We start with the number that's added or subtracted. The number that's added is 1, so we subtract 1 from both sides. We cancel this. 1 minus 1 is 0. So we have 3x equals 4. And then we need to isolate x, so we still have a problem here, the number 3. The number 3 is multiplied by x. If it's multiplied by x, then we divide by it in order to cancel it. So we divide by this number, we divide both sides by this number. As we can see, 3 over 3 is 1. 1 times x is x. So on the left-hand side, we have x. On the right-hand side, we have 4/3. This is the solution. This is the solution of the equation, or the root of the equation. And we can write it using the set notation. So we can write the solution set is we put it inside set notation. This is called set notation, and we put the answer here inside these curly braces. Now let's take another example. If we have 2x plus 3 equals 4x plus 1. Here in this equation we have x written more than once, as we can see. So in this case we need to write it as 1x. So we don't want to see more than 1x in the same equation. So what should we do in this case? We look at the smallest, or the smaller coefficient of x. The smaller coefficient is 2. 2 is less than 4. So we subtract that term, negative 2x, from both sides. Now 2x minus 2x is 0. We are left with 3 on the left-hand side. On the right-hand side, we have 4x minus 2x is 2x plus 1. Now we have an equation of the variable x written once. We need to isolate x. So in order to isolate x, we start with the number that's added or subtracted to this term. So we have 1 added, so subtract 1 from both sides. You get 3 minus 1, 2 equals 2x, and then 2 multiplied by x. In order to get rid of the 2, we divide both sides by 2. So the equation the answer is x equals 2 over 2, which is equal to 1. So the solution set is 1. Now sometimes we have more complicated equations. For example, we may have 3 times 2x minus 4 equals 7 minus x plus 5. Here x appeared twice, here and here, but before we do anything, or we deal with this x, or before we isolate x, we need to simplify the equation. Simplifying the equation, that means by simplifying, we mean to get rid of the parentheses in the equation. So how to do that? We need to distribute 3 on the left-hand side parentheses. So this gives 3 times 2x, that's 6x. 3 times negative 4 is negative 12. That's the left-hand side. Now on the right-hand side, we have 7 minus. Now we insert minus on this parentheses, so we change the signs of x and 5. Now we have an equation with no parentheses. As we can see, we have x. Now, before we simplify, look at the right-hand side. We have 7 and minus 5. So let's write this as 2. Because 7 minus 5, 2 numbers, we can subtract them. So we have 2 minus x on the right-hand side, and 6x minus 12 on the left-hand side. Now, since we have x written twice, we need to get rid of the smaller one. So the smaller one is negative x. So we add that x to both sides. This becomes 0. We have 6x plus x, that's 7x, minus 12 equals 2. And then we add, now we have an equation, linear equation, that's almost written in the standard form. So because it's very easy to solve it. We solved several problems here on this idea. So in order to isolate x, we need to look at the number that's added or subtracted, and add the inverse of that, or the the opposite of that number. If we have negative 12, we add 12. So we have 7x equals 14. And then to get rid of the 7, we divide both sides by 7. So x equals 2. That means the solution set is 2. As we can see here, the solution set consists of one element, just one element, because it's linear equation. For linear equations, we have at most one solution. Sometimes we don't have any solution, but we can't have two solutions or three solutions because this is linear equation. This is just when we graph it, we have a line that intersects the x-axis at one point, and that point is the solution. That's what we mean by solution of an equation. The solution is the points where the function or the equation, the graph of the equation intersect the x-axis. Okay, now let's take another example. Now, before we take another example, we can check our answer. We can check the answer here. We got x equals 2 as a solution. We can plug it back here. So we have 3 times 2 times 2 minus 4. This is the left-hand side. We simplify. 2 times 2 is 4. 4 minus 4 is 0. 0 times 3 is 0. That's the left-hand side. Now what about the right-hand side? The right-hand side is 7 minus x plus 5. Now we substitute 2. We have 7 minus 2 plus 5. And that's 7 minus 7 equals 0. The right-hand side is 0 as well. Those are equal. That means our solution is correct. And this is how we check our answer. We just plug the value that we obtained or the solution that we got into the original equation. Now let's do another example. We want to solve the equation 2x plus 4 over 3 equal plus 1/2 x equals 1/4 x minus 7/3. Now we want to solve this. So how to solve this equation? We have x written more than once. So we can simplify this equation by looking at the denominator. The denominators are 3, 2, 4. So if we multiply by 12, then we can get rid of these numbers because these are divisors of 12 or factors of 12. So multiply each term by 12. So the first term multiplied by 12, the second term multiplied by 12, third, in the right hand side we have 12 times 1/4 x minus 12 times 7/3. Now we can simplify. 12 over 3 is 4 times 2x plus 4 plus 6x equals 12 over 4 is 3x minus 12 over 3 is 4 times 7 is 12. Sorry, 28. Okay, now we need to simplify to get rid of the parentheses first. So we distribute 4. 4 times 2x is 8x. 4 times 4 is 16 plus 6x equals the right hand side. And then we have 8x plus 6x, that's 14x plus 16 on the left hand side. On the right hand side we still have same expression. Now we have two x's, or x repeated or written twice. So we subtract the smaller one. The smaller one is 3x. Subtract 3x from both sides. You get 11x plus 16 equals negative 28. Now we have an equation that's almost written in the standard form. So we can subtract 16 from both sides. And we get 11x equals negative 44. And then we divide by the coefficient of x. We get x equals negative 4. So the solution set is x equals negative 4, which is written in the set notation. Now, by looking at equations, linear equations, we have three types of equations. We have identity equation. That means the equation satisfies or satisfied by any number. For example, 3 times x plus 1 equals 3x plus 3. Now let's simplify the left-hand side. We distribute 3. So we have 3x plus 3 equals 3x plus 3. And if we look at the left-hand side and the right-hand side, they are equal. Since they are equal, we can plug any value and that equation is still true. Let's simplify. Let's subtract 3 first. We get 3x equals 3x, and then divide by 3 both sides. You get x equals x. And that means if you substitute x equals 1, you get 1 equals 1. If you substitute x equals negative 10, you get negative 10 equals negative 10. So this is correct for all values. So all values will satisfy this equation. This is called identity, if the left-hand side is equal to the right-hand side. The second type is called conditioned or conditional. Conditional, that means we get one solution. As we've seen in all the previous examples, we got one solution, and that means we have a conditional equation. For example, there is a solution, and that's one solution for this for linear equations. For example, 2x equals 4. In order to solve this, we divide both sides by 2. We get x equals 2. So we got a solution, and that's called conditional equation. The third type is called contradiction. Contradiction means the left-hand side is not equal to the right-hand side. We get a false statement. For example, if we have x equals x plus 1, let's solve this equation. We have x written twice, so we need to get rid of one of the x's. Those are equal, so we subtract x from both sides. We get 0 equals 0 plus 1. 0 equals 1, but 0 is not equal to 1. That's contradiction. This is contradiction. So this type of equations is called contradiction. So here, no solution. So if you try any value, you can't get a correct answer because x cannot equal x plus 1. Even if you substitute 0, you get 0 equals 1, and that's not correct. Now let's do some examples. For example, if you have negative 2 times x plus 4 plus 3x equals x minus 8. In order to solve this, we distribute the negative 2x negative 8 plus 3x equals x minus 8. And then we have negative 2x plus 3x is just x minus 8 equals x minus 8. If we look at the left-hand side, that's equal to the right-hand side. So let's add 8. You get x equals x. And this is true for all x values. So that means we have identity. This is called identity equation. Because if you subtract here, if we subtract x, we get 0 equals 0. So if we get same number, 0 equals 0, 1 equals 1, and so on, that means we have identity equation. Let's do another example. If we have 5x minus 4 equals 11, now let's add 4 to both sides. We get 5x equals 15, and then we divide both sides by the coefficient of x. We get x equals 5, and that means we got one solution. This is called conditional. The last example is 3 times 3x minus 1 equals 9x plus 7. Let's solve this equation. We distribute 3 on this expression. We get 9x minus 3 equals 9x plus 7. We add 3 to both sides. We get 9x equals 9x plus 10. And then we subtract 9x from both sides, we get 0 equals 0 plus 10, and that 0 equals 10. This is impossible, so we have contradiction. So the solution, what is the solution? There is no solution in this case. Or we can write the solution set as an empty set. We don't write anything inside the curly braces. Or we can use phi. This notation means, or phi notation, this is read phi, and this means empty set. Now that was section 1.1. Let's move to section 1.2. Now section 1.2 about modeling with linear equations. Here we have some steps. First, we read the problem, and then we assign a variable. And then we write an equation. Then we solve the equation. And then we state the solution. And then if we want to check the answer, we can, to make sure that our answer is correct. So we have 5 or 6 steps. Let's take an example. If the length of each side of a square is increased, and the word increased is very important here, is increased by 3 centimeters, the perimeter of the new square is 40 centimeters, or 40 centimeter more than twice the length of each side of the original square. The question is, find the dimensions of the original square. Now here for this problem, we first read the problem and then we assign a variable. So after reading this problem, we need to assign the variable. We usually assign the variable for the smaller quantity. So here we have 2 squares, original and new square. For the original, let's denote the sides of this, the original square, by x. So the length of each side of the original square is x. Now the new one, the new square, is increased by 3. So if this is x, the corresponding one will be x plus 3. So this is x plus 3. Now we already assigned variable. 3, we write an equation. The equation, we are talking about the perimeter of the new square. The perimeter is the sum of all sides. So we have 4 sides, so 4 times the length of each side of one of the sides, it's x plus 3. Now this is equal to 40 more than 40, more means plus, more than twice to the length of each side of the original square. The length of each side of the original square, that means x. So here, this is how we write the equation. Now after writing the equation, step 4 is to solve. We solve as we learned in the previous section. We have 4x plus 12 equals 40 plus 2x. And then we subtract 2x from both sides because 2x is less than 4x. So subtract 2x. You get 2x here on the left hand side plus 12 equals 40. And then we solve this equation by subtracting 12 from both sides. We get 2x equals 28. And that means divide by 2 both sides. You get x equals 14. So the solution set is 14. Now, step 5, we state the solution. So to state the solution, we write each side of the original square measures 14 centimeters. If we want to check, we can substitute here. We have 4 times 14 plus 3. This is the left hand side. This is 4 times 17. And that gives 68. On the right hand side, is this equal to 40 plus 2 times x? X is 14. Yes, this is 68. The left hand side is equal to the right hand side. That means our solution is correct. Now the last problem here is the following. We have 2 persons, Mona and John, are traveling to a conference. The trip takes 2 hours for Mona and 2.5 hours for John, because he lives 40 miles further away. Now John travels 5 miles per hour faster than Mona. The question is, find their average rates. Okay, now the first step is to read the problem. First read, and then we assign a variable. As we can see, we have 2 quantities. One of them is less than the other one. The 2 rates. Mona's rate is smaller than John's rate, because here we have 2, here we have 2.5 for John. So that means we denote by x Mona's rate. So we usually use x for the smaller quantity. And if x is Mona's rate, John's rate will be 5 more than Mona's rate. So it's x plus 5. So we assign variables. Now the third step is to write an equation. Now how to write the equation? To write the equation, we first have x for Mona's rate, and x plus 5, that's John's rate. And then we have 2 hours. It takes 2 hours for Mona to arrive. So that means we multiply x, the rate, Mona's rate, by 2. And it takes 2.5 for John to arrive, because his rate is, now he lives 40 miles further, but his rate is x plus 5. That means we multiply x plus 5 by 2.5. Now it takes him, or John, 40 more, and that means in order to set these equal to each other, we need to add the 40 for Mona, because Mona's rate is less than John's rate by this quantity, by some quantity, and that means we need to add the 40 to set them equal to each other. Now, after writing the equation, we solve the equation. Now we try to simplify the right hand side. We have 2.5x plus 2.5 times 5, and that's 12.5. And then we have x written twice, so we subtract the smaller x, the smaller term. We have 40 equals 0.5x plus 12.5. And then we subtract 12.5 from both sides. We get 27.5 equals 0.5x, and then we divide by the coefficient of x. We get 27.5 over 0.5, and that gives 275 over 5. This is equal to 55. That's the solution set. Solution set, or that's the solution, and then if we write it as a set, we use the set notation. So x equals 55, and then we state the answer. So Mona's rate of travel is x. It's x, and x is 55. And John's, we write it here. Now John's rate of travel is x plus 5. So we need to add 5, 55 plus 5, and that's 60. 60 miles per hour. This is the unit. And that's it. Now if we want to check, we can plug into this equation to check our answer. So we can write 2 times x, x is 55, plus 40. Is it equal to 2.5 times 55 plus 12.5? If we simplify, we find that the left-hand side gives 150, the right-hand side gives 150. So our answer should be correct. Let me double check something here. 2.5 times x plus 5. 2.5 times x plus 5. So this should give you 150, and that's how we solve models. This is called model because, or the equation, actually here we are modeling this problem. This is a problem, and we are modeling problem. We mean by modeling problem to write it as an equation.